All right, in this lesson, let's go ahead and compile our model. All right, we're getting down to the end here. Step 5, compile the model. After we define our model, it's time to compile it. Compiling the model uses numerical libraries under the hood. We call that the back end, such as Theano and TensorFlow. And in a minute, when we walk through the entire process, you're going to see Theano being used. The backend automatically chooses the best way to represent the network for training and making the predictions to run on your hardware. When compiling, you must specify additional properties required when training the network. Remember that training the network simply means finding the best set of weights to make predictions for the problem. We must specify the loss function used to evaluate a set of weights. The optimizer uses this to search through different weights for the network and any other optional metrics we would like to collect during the training part. In our case, we're going to use a logarithmic loss, which for a binary classification problem is defined in Keras as binary cross entropy. Log loss quantifies the accuracy of a classifier by penalizing false classifications. So we want to minimize log loss. Minimizing log loss is basically equivalent to maximizing the accuracy of our classifier. All right, so up here, you can see that I have defined a little bit that you can read through, but it gets deep quickly. So if you want to read more, again, defining these, right, cross entropy, this is a special kind of cross entropy. Why? Because remember we said in our output, we have a 1 or a 0, right? So we're working on a binary classification problem. So this is a binary cross entropy. So that means we kind of have to define what cross entropy is. Again, beyond the scope of the course. We also use a efficient gradient descent algorithm, ATOM, and we do that because it's default. Again, the specifics of ATOM are outside the scope of this course. But as an optimizer, you're going to see ATOM used a lot. Metrics, so what is our metric, right? Well, we said accuracy. Remember we said log loss is equivalent to maximizing accuracy, all right? So we're going to use accuracy as the metric to define how well a model does. And accuracy is kind of the de facto way we evaluate a model.